Alright, so I want to give a heads up on how to work out Punnett squares. So hopefully a really quick tutorial. Punnett squares are very similar to multiplication tables. So for example, in a multiplication table, this section would be 1 times 2, which would be 2. This section would be 3 times 2, which would be 6. This section would be 1 times 5, which would be 5. And if you asked you what this one was, you would say from above. You see there, the 3 times the 5 would be 15. So if I ask you to fill out, a times table, a multiplication table similar to this, you should be able to give me those answers, and I think most of you would be able to do that. With Punnett squares, we do the same thing, but instead of it being numbers on top and numbers on the side, we've got the dad's genotype over here, and the mom's genotype over here. I'll change these. So that's going to be individual letters. So let's just say we were to do an A and an A. I'm sorry, capital A, little a, capital A, capital A. So without going into much about this, this is the genotype for the dad. So in the same way we did the multiplication, we would bring down a capital A and a capital A. Right here would bring down, because capitals go first, we'd do a capital A, lowercase a, capital A, capital A. Over here would be a capital A, lowercase a. So if we go into doing another Punnett square, I'll do just another one over here. So we've got, let's go big A, little a, big A, little a. I'm not sure why that's not bold. So right here in this box would be big A, because you come down and over. Coming down, you have a little a and a big A, so we're going to put those in. Big A, little a. Again, big A, little a, little a, little a. So let's just say Punnett square was a little bit different. Let's say you were given this information. Well, you know that one of these two is a dominant gene. So let's do a big R. Let's see if this works. Big R, little r. Would that make sense? Let's see. Let's just type this in and see if it works. That does not make sense because this box could not have 2 big R's on it, so that's not right. If you need to, you can sometimes just do trial and error. Let's try this. Big R, little r, little r. We've got, this one would be big R, little r, big R, little r, big R, little r, big R, little r. So if there are times where you're given the boxes, what the actual offspring are, and you have to go off of that to figure out what the parents are. So example, I could work backwards and know that I know both of these are going to be big B. And since I know this one's going to be giving a big B over here, this one must be a little b. And if I look at the same thing here, I know this big B is going to come down to here, so this must be a little b. So this is a little bit more difficult doing it these two ways, but it is possible you can do that. All right, so let's jump back to this this one over here. Let's just say this is this shows that somebody has. Let's change it to be. I don't know. They have. Let's put a key down here. Big A equals brown hair. Little a equals blonde hair. The letters do not matter. They do not have to match. All right, so we have our little key. We'll drop this down here so we can see it. So we've got big A is brown hair, little a is blonde hair. So if I were to look at this, we can change these words from what we've learned in class. We can change these words homozygous dominant to big A if we needed to, and heterozygous would be big A, little a, and homozygous recessive would be little a, little a. So if we were to ask what the percentage of these were, so what is the percentage of big A? So there's 1 out of 4, which if we know that each of these are 25%, then that's going to be just 25%. One of them is 25%. There are 2 out of 4 that are big A, little a, heterozygous, so that's 50%, and there's 1 left over, that's 25%. Now if you got that, that's great. If not, here, let's look at it over here. Let's change these letters. So if we replace this, chances of brown, and again, probability is the probability of something happening. I mean, the Punnett square is the probability of something happening. So the chances of brown is going to be this one. This person is going to be brown. Their hair is going to be brown. This person is going to have brown hair, and this person is going to have brown hair. So that's 1, 2, 3 out of a total of 4 boxes, and that percentage, 3 out of 4, is 75%. You can either do that math in your head or use, write it out or whatever. Chances of blonde, well, this is the only one that ends up blonde because it's the only one that has all recessive genes. So that's 1 out of 4, which is 25%. These percentages should end up equaling 100, and this one does. Another thing that they may ask is how the dominant phenotype, which in this case would be brown, like it says over here. This one would be brown. This one would be blonde. So in this case, the percentage that are blonde, we just saw here, is 75. And if you have to do the whole 1 out of or 3 out of, then you can, but eventually you'll get to the point where you don't have to do that. And you'll know each of these is a quarter, 25%, and add them up. So that should help with different worksheets that we'll be doing in class. Should help with your test if you're not sure, and if you're still not sure after this, then you can ask questions.